Hello everyone. In this session, we are going to discuss about the ninth exercise of the DLT lab programs. And this is based on the CNN, Convolutional Neural Network. So the problem statement is design and implement the CNN model to classify the multi-category JPG images with the TensorFlow and Keras and check the accuracy. So we have to take the JPG files. So we have identified some data sets. Out of that, I am taking the source from the Kaggle flower dataset, and it was given in the Google Drive also. This is the link. And if you open that link, we are having 5 types of flower images are available. So if you open this is the tulip flowers. All the tulip flowers are available. And in the previous thing, sunflower, these are the sunflower images, all the sunflower images, and orchid, and then lotus images, and then lily images. These are the various images available, classified, and labels are given. So actually in the original data set there are 1000 images for each category, but we have reduced that for simplicity. And for this data set, what should we do is we have to fit the classification model to predict the flower name for the given image and check the accuracy. This is what we have to do. Design the CNN model. Let us start with this. Already you have gone through the image loading programs in the previous exercises, that is in the lab 5. In the lab 5 you have loaded the images, so you can go through that method for analyzing how to load the images. So this is, we have to mount the drive. Yeah, there are some sessions are running. Yeah. Connect to the drive and my drive, giving the permissions. Yeah. So it is getting mounted. So I'm loading I'm importing the required libraries, and I'm trying to execute them. All these are already we have done with the previous exercise, that is lab 5. In the lab 5 we have done this, and I'm just displaying one image, loading the image by using the PIL image.open, and we are just displaying the image. Yeah, it is a lotus. And now we have to load the data set. So for the loading the data set, it is the standard method we are using from first program onwards. So it is covered in the image handling 1 and 2, and then we have used this in the lab 5 also. So we are defining a method load imgs with the path, and we are loading the images and labels, preparing the labels. In this, the label is the directory name, so that we are giving the I represents the directory name, J represents the file name, so that the directory name, if you see that the directory name, tulip, sunflower, lotus, lily, all these are the directory names, they are the labels. So I am giving the labels. And one more important point to be noted here is the flatten. We should not flatten. We have to remove the flatten, because this is the convolutional neural network. As we discussed in the theory, the convolutional neural network will take the 2-dimension or 3-dimension images, and it will take the kernel, it will move over the images, over the image to get the convolutional feature map, and then it will go with that. For that, we have to go for the two-dimension image to consider the surrounding pixels. So don't flatten it. So we can execute this. I want to load the images and labels. I want to prepare the data set. In the preparation of the data set, it is loading the data set. We have total five types of flowers are available. I remember that I have given only 500 images for each folder instead of 1000. So we are going with that. So the images are loaded. Now I want to display the shape of the images. So it is 2502 images are there, 32 by 32 each image, and it is the RGB. That's why it is giving the 3 layers, that is RGB, and labels also 2502. And I want to display the labels. So these are the labels. We have to convert that into the numerical formats. So for that, I'm converting the given list, labels list, into the series, pandas series, and I'm taking that as the category. T type is category. This is a pandas concept. You can refer the pandas concept to get clarity on this. And then L codes equal to, I'm just getting the category codes for this, for the labels, and I'm taking them into the L codes, and lcodes dot value counts. So for that, I'm going with this. If you execute 501, 501, 501, 500 and 499, these are the images, number of images for each category. 0, 1, 2, 3, 4. These are the categories. And then we are going for the train test split for the data set. Train X, train Y, test X, test Y we are giving, so that here 2001 images are in the training set, and 32 by 32, 500 images, 501 images are in the test set. That is also random, shuffle equal to true, so that random images will be taken in the test data set. Now we are building the convolutional neural network. It is like our regular neural network only, ANN only. Only the difference is we have to add the conv2D. Conv2D is the layer to represent. Here the conv2D, we have to import the conv2D. After applying the convolutional, you have to flatten the feature map. In the ANN, first we are applying the flatten and then giving it to the model. But here we have to create the feature maps. Those feature maps have to be flattening. So for that also there is a layer available, that is a flatten layer, and dense layer anyway we have to classify. If you want to classify, dense layer is required. So conv2D. In the conv2D, simply we have to create the sequential model, and model dot add of conv2D. We have to mention how many number of filters. How many number of filters we have to provide. That is 16 filters I am taking, and then 3, 3. That is kernel size is 3 by 3. 3 by 3 kernel will be moving over the image, and it will get the feature map as we discussed in the theory part. So input shape, instead of input dimension, in the previous case we have given the input dimension. Here we have to provide the input shape. Actually we can give the input shape as 32, 32, 3. We can provide that. Instead of that, we can take that trainx, already trainx.shape is available. Trainx is there. Trainx.shape, if you observe here, trainx.shape will give you this. In this, our image size is 32, 32, 3. We have to take this. This is a tuple. This is the Python basics. I'm getting this. See here, trainx.shape. I'm giving the trainx.shape, so that it is giving 2001, 32, 32, 3, and then out of that I want to take from one column, meaning that this is the 0 location, first location, second location, third location. I want to take from 1 onwards all the remaining values, that is 32, 32, 3 will be taken, so that will be taken here. So if you want, you can write that here. Train underscore x dot shape of shape. Simply if you give this, that will be displayed, and of 0, if you give of 0, you will get 2001, meaning that those many number of images. I want to get from first location 32, from 32 onwards. So 1 colon if you give, it will give you 32, 32, 3. So here I have to represent that only. Okay, and then activation is ReLU as usual, and I'm adding only one convolutional layer. I'm trying with that. If it is not working, we can go for the more convolutions. We can add one more convolution with a number of filters, and you can use the kernel size also. Actually, we are using 3 by 3. You can use 5 by 5, 7 by 7. Generally, it is the odd number. Generally, we will not take the even number because we have to represent the middle pixel. So, to take the middle pixel, you should go for the odd number for the kernel size. Okay, and now after convolution, we will get the feature maps, and that feature map has to be flattened so that we will get the single dimension array, and then we can apply the dense layer of 32. I am taking 32. This is also we can take as your wish, and then dense of 5. This is fixed because how many number of classes are there? This is the output layer. For the output layer, 5 classes are there in our data set, 5 types of flowers. So I am taking dense of 5. Activation is softmax because there is the classification, multi-class categorization. So that we are going with that. And then compile the model with the sparse categorical cross entropy, and optimizer is Adam. I am taking the accuracy as the matrix, and summary, we are just displaying the summary. After that, we are fitting the model, that is train the model. So let us train the model. Yes, this is the model, and then so this it is getting trained. I think it is getting stuck somewhere. Slowly, it is slowly may get trained. Yes, I think it is 24, 27. Slowly increasing. If you want, you can increase the number of epochs also. See here, you can increase the number of epochs, or you can add one more layer here. Model that add of conv 2D of this. Now I am executing with 2 hidden layers. I think it is better. There is no guarantee that one layer will give you good training, 2 layers may give good training. There is no thumb rule for that. So see here, if you add one more layer, it is getting trained very fast. It is not true for all the cases. The accuracy may be down for some cases if you increase the number of layers. We don't know that. Right? See here, 11 epochs out of 25, 12 epochs. Already we reached 99 accuracy. And you have to observe the loss also. Is it getting down or increasing? It may be increased, it may be decreased, we don't know. So this is because of the various values changed in the weights because of that. So 22nd epoch. '24th epoch, 99%. Sometimes it is reaching 100% also. So yes, it is over. Now I want to go for the test data set. So I am predicting for the test data set. See this, the test data set accuracy score is just 60. So it is overfitted. Of course, we need not handle the overfit in this exercise. We can skip this. And then I want to predict the label for the image. Same as the previous case, we are pre-processing the image, given image. We are defining one method and we are loading one image and we are displaying the image. The image, it is sunflower, because we scaled it to 32 by 32, so it may be blurred. You can observe that these are the pixels. This is the pixel. Okay, and now I want to predict. I want to predict the label. It is 4. What is the 4? I don't know. So I am going with the mapping between the labels from the labels we are getting, labels dot category dot categories. This is also from the pandas concept, pandas series concept. So we are getting that. So I want to get, see this is the tulip. This because it is the overfit, so it is, the prediction is wrong. Actually it is the sunflower. We have to get the sunflower, but it is giving as the tulip. So there may be the chance, and if you want, you can train it more by adding number of layers, and you can continue this. Thank you.